to our channel BA Civil Engineer. In this video we are going to discuss about foundations and types of foundations. So let us move into the video. What is foundations and what are the types of foundations? So coming to foundations, the basic function of the foundations, if you see, the basic function is to transmit the load from building to the soil. Means from the superstructure to the substructure, the load is to be transferred. So that is the basic purpose of the foundation. So that was discussed here. So in order to transmit the load from the subsoil in such a way that settlements are within the permissible limit. So when the load is going to be transferred, from the superstructure to the substructure, so because of that load which was transferring to the subsoil, there may be some settlement in the subsoil. So what should happen here? The settlement should be within the permissible limit. It should not be more. It should be in the permissible limit. So the basic function of the foundation is to transmit the load from the building to the subsoil in such a way that the settlements are within the permissible limit. Second one, the soil does not fail in shear. It should not fail in shear. This is very important point. So when the load is going to be transferred from the superstructure to the bottom of the foundation or to the subsoil below the foundation, the soil should not fail in shear. It should not undergo failing. So if it is failing up, collapse of soil will be taking place. It leads to uneven settlements in the foundation, and it may lead to damage in the structure. And in order to reduce the load intensity, next the another important purpose of the foundation is to reduce the load intensity which was acting on that particular area. So the load distribution should be taken place in a trapezoidal manner. Trapezoidal distribution will be taking place. Here I am showing you trapezoidal distribution. Load is going to be transferred in a trapezoidal manner. Next, even distribution of load. Load should be evenly distributed. Uniform distribution of load is to be taken place. Uniform load distribution should be taken place. Next, in order to provide a level surface, the surface should be smooth, or uniform surface or a level surface is to be there for the superstructure what we are constructing. So that is the reason this foundation is very much essential. So this is the importance of the foundation. Now we will see what is the type of the foundation. So now coming to types of foundations. So the foundations may be broadly classified as two types. The first one is the shallow foundations and second one is the deep foundation. So shallow foundation, what is this shallow foundation? If you see, the foundation which was laid at a shallow depth below the ground surface, it is referred as generally a shallow foundation. Next, if you see, the depth of foundation is nearly equal or less than the width of foundation, then also it is said to be shallow foundation. So if the depth of foundation is very much large when compared to the width of the foundation, then it is referred as deep foundation. So the shallow foundations are also known as open foundations. Why? Because they are done by doing opening operation or excavating the ground surface. The ground surface is going to be excavated completely, and then we are going to do this complete operation. So that is why the shallow foundations are also known as open foundations. They are known as open foundation. Next, deep foundations. So coming to the deep foundations, if the depth of foundation is very much large when compared to the width of the foundation, if the depth is very much large, if the D is more than B of the foundation, then it is called deep foundation. If depth is less than or equal to B, then it is referred as shallow foundation. So in the shallow foundations, if you see, it can be further classified as a spread footing, combined footing, strap footing, mat footing or raft footing. So these are the basic classification in the shallow foundations. Spread footing, combined footing, strap footing, raft footing or mat footing. So these are the basic classification of shallow foundation. Next one, if you see, coming to the spread footing. So what is this spread footing? The spread footings are those which spread the superimposed load on the load of the wall or the column over a large area, where the load is going to be distributed greatly, where the load coming from the either wall or from the column, the load which was coming onto the foundation below, that is going to be distributed uniformly, then it is called a spread footing. It is going to spread the load. The spread footing either support column or wall. It is capable of supporting column as well as wall. In both cases we are going to use the spread footings. So there are so many types of spread footings: single footing for column, stepped footing for column, stepped footing for column, slope column, wall footing for step, grillage foundation. All these are different kinds of spread footings. So here you can see in the image uh, sloped footing, sloped column footing, single column footing, simple wall footing, it is a wall footing, simple column footing, stepped wall footing, stepped column footing. So all these are different types of spread footings only. All these are isolated footings. Spread footings are also known as isolated column footings or isolated wall footings. So here you can see grillage foundation. So it is a composite. Both iron and concrete are going to be used here in laying this kind of individual footing or spread footing. This is what we call grillage foundation. Next, combined footing. So a spread footing which supports two or more columns. If two or more columns are supported, if two or more columns are supported by a, if two or more columns are supported instead of two individual footings, if you are laying a single column in order to support two columns, in order to support two columns, if you are laying a single footing, then it is called combined footing. So here you can see in the figure, these two are the two columns. This is one column and this is another column. These two columns are supported by a rectangle like this. So this is a combined footing. So a spread footing which supports two or more columns is termed as a combined footing. So the combined footing may be of two types. It may be a rectangular combined footing or it may be a trapezoidal combined footing or combined wall footing. For walls also will be using combined footings. So combined wall footing or rectangular combined footing or trapezoidal combined footing. So if the columns are having sufficient space on both the sides, then we can adopt column footings or rectangular combined footings. But sometimes one column will be at the end of the property line, then in those cases, or both the columns will be at the end of the property lines, where other end of the column or the half portion of the column may be unable to extend beyond the column line. So that is why half portion of the footing may be unable to extend beyond the footing line. So here, for example, here this one is the property line, means this portion of footing we cannot, this portion of footing we cannot lay here if the property line is at 1. Similarly, if the property line is at 6, if it is there, then also it is unable to lay foundation here beyond this 6. So in those cases, we'll be adopting a combined footing, a trapezoidal footing will be adopting like this, so that it will balance the moments, the bending moments what were coming over there, and the stability of the footing is going to be balanced over there by adopting trapezoidal combined footings. If no problem like that, then we'll be going for simply rectangular combined footing. And combined footings are mainly adopted if the spacing between the two columns is very less. If this spacing is very less, then only we'll be adopting this combined footings. One has to remember this point. Combined footings are adopted only when if two columns are very close to each other, so that when the two columns are close to each other, if you see the diagram, two columns are there, two columns are very close to each other, then what happens is the pressure bulb diagram. If you see the pressure bulb distribution, both the pressure bulbs will be lapping each other. So here the stress will be double impact will be there. The stress intensity will be very much more, and it may leads to collapse. So that is the reason we'll be adopting combined footings in order to overcome that problem. So this is about combined footings. Next one, here you can see the trapezoidal footing. Trapezoidal footing, as I told, mainly in the cases where the property line is very close to column. So here it may be property line. Here it may be property line. Here it may be property line which is very close to the footings. Then we'll be using this trapezoidal footing. Strap footing. So if the independent footing of two columns are connected by a beam, then it is called strap footing. So as strap footing may be used where the distance between the column is so great that trapezoidal footing becomes quite narrow. So if the distance is very much large, if the two columns are separated by a large distance and combined footing is very much essential there, in those cases we'll be adopting this strap footing. Means additionally, instead of adopting a combined footing, we'll be providing a connecting between the two beams of the two columns by a strap, by a connecting beam like member. That is what we call strap. So here in the picture you can see, if you observe the picture, everyone can clearly see here, this is the individual column, and here it is a combined footing, here it is a strap footing. This is the strap. The violet color portion it was shown here is the strap which was provided here in between the two footings. In order to connect the two footings, we are providing a strap here. So next one, raft footing. Another important type of shallow foundations is the raft footing. So it is a combined footing that covers the entire area beneath the structure and supports all the walls and columns. All the walls and columns are supported with a single mat-like footing. Then it is called mat footing or raft footing. So where we are going to use this mat footing means if the soil is very weak, if the bearing capacity of the soil is very less, in those areas we'll be adopting this raft foundations. Here it was shown. They are used in the areas where the soil mass contain compressible layers of soil which are sufficiently elastic so that differential settlement will be more, and it will be difficult to control that differential settlement. So in those areas only we'll be using this raft foundation. Mainly in the expansive soils also we'll be adopting these raft foundations. Why? Because they are highly plastic and they are highly active. In case of highly active soils also we'll be using raft footing. Why? Because uneven settlements may occur in the foundations. So this is about shallow foundations. Figures related to this raft foundation. So here you can see all these are columns. All these columns are connected with a single mat as a rectangular footing. All these are connected with a single mat as a rectangular footing. So this is the raft footing. In field also it will be very much complicated. Here you can see field picture where the raft is going to be prepared for laying of the concrete. So the raft will be a vast footing, means a large area. The entire foundation or the entire floor area is going to be provided with foundation with reinforcement and concrete. We are going to provide a mat foundation which is going to distribute the load evenly in the cases of highly compressible soils and in the case of highly susceptible soils. Coming to the deep foundations. So among the deep foundations, pile foundations and well foundations are the more prominent deep foundations. Before we go for these pile foundations and well foundations, if we see the necessity of deep foundations, so where we are going to use these deep foundations, there are 3 to 4 areas where more prominently these pile foundations are adopted or deep foundations are adopted. So firstly, if we see where the hard soil strata is available at a greater depth. So once again, you remember the definition. Deep foundations means if the depth of the foundation is much larger than the width of the foundation, then it is called deep foundation. So in this deep foundation also, where we are going to use these deep foundations, if we see, firstly, if the hard strata is available at a greater depth, if the depth of availability of the hard strata is somewhere 30 meters, 40 meters or 50 meters or 100 meters, then we'll be going for deep foundations instead of shallow foundation. Next, another one, a very weak strata or a very highly compressible strata is available at the ground surface or at a shallow depth. If the soil available is very weak, then also we'll be adopting deep foundations. So that is another case. Third one, if we see, these deep foundations are adopted on the river banks. When you are constructing a structure or when you are constructing a bridge or when you are constructing a dam on the river shore or on the river side, then we'll be adopting, or in the case of sea also, when we are working on the sea or when we are constructing in the sea, we'll be adopting these deep foundations. Next one, in the case of layered soils, also the load distribution may be greatly affected. Why? Because of existence of weak strata in between. So that is why in those cases also we'll be distributing the load by means of these deep foundations. So these all these are areas, different areas where we are going to adopt these shallow foundation, deep foundations. Okay, so firstly, if we see among the deep foundations, pile foundations is very important. On the screen we are having pile foundations. So what is this pile foundations? If you see, so it is the type of foundation in which the loads are taken to the lower level by means of vertical members, which may be of either timber, concrete or steel. So we'll be taking a solid or hollow vertical members, either it may be made of timber, either it may be made of concrete or steel. Those vertical members are used for the distribution of load. Then those foundations are called pile foundations. So pile foundations may be adopted when no firm bearing strata is available and the loading is uneven. So 2 cases it was discussed here. So if no firm bearing strata, means if the bearing capacity of the soil is very low at the top or at the shallow depth, if no hard strata is available in that particular shallow depth, then we'll be going for pile foundation. Next one, if the loading is uneven, if uneven loads or vibratory loads are acting on that particular soil, then also we'll be going for pile foundations. So piles may be of 2 types. On basis of the load distribution, if we see, the piles can be classified as 2 types: end bearing piles, friction piles, compaction piles. So what is this end bearing piles, what is this friction piles, what is this compaction pile? So end bearing piles means the load is going to be distributed by the tip is going to distribute the load. So it is the tip of foundation, this is the pile, and this is the tip. So the tip is going to distribute the entire load. So the load is going to be distributed at the end of the pile. So the end is going to bear the entire load. So that is what we call end bearing piles or tip resistance we call. So that is if the tip resistance is more and the load is going to be distributed by the tip only, then it is called end bearing piles. Next one, friction piles. What is this friction piles? If you see, if the load distribution is going to take place by the frictional resistance along the surface of the pile, if the because of the frictional resistance the load is going to be transferred to the surrounding soil, then it is called uh, friction piles. Third one is the compaction piles. Compaction piles means by means of compactive forces it is going to transfer the load. Because of the compactive forces it is going to transfer, then it is called compaction pile. So here you can see uh, all the three types of piles: end bearing piles, friction piles, and a combination of both end bearing and friction piles, that is compaction piles. So here end bearing piles, the load is going to be transferred to the bottom only, here only. Here the load is going to be transferred by means of the skin friction. Here both the skin friction as well as the tip resistance, so both all the two are going to act here in the case of combined piles. So compaction piles means if the pile is going to be laid by inserting the solid column or solid shaft into the ground by means of uh, compaction. By means of compaction, if you are going to drive the pile below the ground surface, then it is called a compaction pile. So here you can see clear from the picture and representation how the load is going to be transferred. This is the end bearing pile. Here it is shown. Next this is the skin friction pile where the load is going to be transferred by means of skin friction. Here skin friction will be more, here tip resistance or end bearing resistance will be more. So both are two different of piles, end bearing piles and skin friction piles. So that can be understood clearly. Another type of D foundations is the pier foundations. So it is similar to pile foundations but little bit different. So the difference is that it consists of a cylindrical column of large diameter to support transfer large superimposed load with a bell at the bottom. So not only the pile or the shaft or a column for load distribution, cylindrical column for load distribution, at the bottom we'll be having a uh, bell mouth or a bell shaped mouth or a bell shaped mouth will be there at the bottom. That is why it is called pier foundation. So it resembles a pier of the column. So pier foundation is shallow in depth than pile foundation. Means the depth of pier foundation will be less when compared to the piles. Piles will be done for a greater depth, 40 meters, 50 meters, 100 meters depth will be going for pile foundation, whereas the depth of these pier foundations will be very less. But it will be also a deep foundation if the hard strata is available at a depth more than the shallow depth and not very much large. In those cases we'll be using these pier foundations mainly in case of dams and in case of bridges we'll be using light bridges or medium bridges, small bridges will be using these pier foundations. Next one is the well foundations. So what is this well foundations? So well foundations are another important type of deep foundations. Well foundations or caisson foundations we call, and also box like structures. These are box like structures or circular structures, cylindrical structures which were sunk from the surface on either land or in water to a desired depth. They are much larger than the pier foundations or drilled caissons. So caisson foundations are used for major foundation works like bridge piers, docks, large waterfront structures, etc., etc. So mainly in case of bridges, these well foundations are more prominently used. Well staining, the components, if you see, there will be a well staining. That well staining will be casted at the site, or precasted well staining will be used, and that will be slowly sunk into the ground. The that shaft, or what we call that well staining, that staining of the well means the hollow cylindrical column, that is nothing but the well staining with the thickness of well. So that hollow uh, well staining will be sunk into the ground by excavating the soil in between the hollow portion from the ground surface. So slowly it will be going deeper and deeper, and that way it will be sunk. So these well foundations are highly effective in distributing the load. For heavier loads and for heavy vibratory loads, will be adopting these well foundations. But this is very much costly, and this is very much expensive, very much risk also. More skilled persons are required when you are erecting these well foundations. Why? Because most prominently tilting and shifting is the major problem which is going to occur with these well foundations. So more skilled persons are required when you are doing with well foundation, or when you are working with this well foundation. So here you can see this is the staining portion. So the concreting will be done in between this hollow portion, and that will be acting as a staining, which will be now the excavation will be done in this portion here. In between this, that excavation will be done, the soil from this inner portion will be removed outside, and the staining will be going slowly and slowly into the ground surface. Over that we'll be having a pile cap and well cap, and over that we'll be constructing the piers for the bridges, if you are speaking about. So this is about shallow foundations and deep foundations. Hope you all understand well. Thank you.